Hello everyone, I hope you're all doing well. In today's lecture, we're going to be talking through Chapter 7. We're going to be looking at sampling and specifically estimating the frequency of behaviors and beliefs. So this is continuing on from Chapter 6, where we started talking specifically about frequency claims, and now we're going to be looking at how sampling relates to frequency claims. Though, as we said in Chapter 6, sampling isn't only used for frequency claims. You can use data obtained through sampling for other types of research. So this isn't specific just to frequency claims. That's just the lens we're going to frame it in for now. And for our chapter overview, we're going to start talking about generalizability, which is our external validity. And we want to ask, does our sample represent the population? Can we be confident of our ability to take the results from our sample and apply those to a broader population? And while we're on the idea of external validity, we're going to talk about interrogating external validity, meaning we're going to think critically about it and decide what matters most in any particular research situation. Is external validity always going to be the most important thing to consider? And the short answer is no, but we'll talk about that later on. And then towards the end, we're actually going to deviate from what's in the textbook, and we're going to talk about some real-world applications of different sampling methods. So I'm going to talk a little bit about some of the research that I've done in the past and show you how we can use good sampling methods to conduct other kinds of research. And in this case, we're going to look at songbird vocalizations, but only very briefly. And so as usual, at the beginning of a chapter, I like to take some time and focus on our key terms that are going to keep popping up throughout the chapter. And so we've already kind of touched on some of these, but we're going to explicitly define them here. So if we care about learning if our sample represents the population, maybe we should start by defining a sample and population. And so when we're doing sampling research, we're talking about a population usually in terms of a population of interest. So our population is not usually going to be the entire world, the whole human population. We're usually going to be looking at some subset of the population. So when we say population, we're meaning population of interest. And that population is the entire set of people or things that we're interested in. So for example, if I wanted to learn more about habits of undergraduate students at universities, then my population would be university undergraduate students. Maybe I'd specify that I care about Canadian undergraduate university students, and that would be my population of interest because that's what I want to look at. Our sample is going to be a subset of our population. In most cases, it's not viable to measure the entire population. So you can take a sample, a portion of that population, to try and measure that subset. And then if we can answer our question and the sample represents our population, if the data from our sample could be generalized to apply to that whole population, then it seems reasonable to use a sample to study whatever we're studying. So if my population was undergraduate, Canadian undergraduate students at a university, maybe my subset would be a couple hundred students from each university that I have access to. So maybe some from the U of A, maybe some from McEwen. If we wanted to be really good about this, maybe we'd take some from another province, having a better sample, but we'll talk about that later. But the sample wouldn't be every single student, it would be a subset of those students. Sometimes you are capable of sampling every single member of a population. And in that case, you're not taking a sample, you're actually taking a census. And our most most commonly seen example of a census is when a country is trying to get a feel for the population of the country. So when Canada conducts a census, they send someone or send a survey to every single household in the country and try and get a measure of absolutely every person in the population. So we're getting a sampling of the whole population of Canada. And, there's always some people that are missed, but the ideal for a census is that you get every single member of that population. But for obvious reasons, that is both cost prohibitive and sometimes impossible. So we're going to be talking about getting a sample rather than trying to conduct a census. Now, one of the things that we have to keep in mind is that we're taking our sample from our population, but just coming from that population is not the same as saying that we can generalize to that population. And this is where our distinction for today is going to come across, where you can have two kinds of sample. One is a biased sample, which is going to be an unrepresentative sample. So you're going to have some kind of discrepancy between the composition of your whole population and the composition of your sample. If your sample is biased, if it's unrepresentative, then the results that you're getting from your sample aren't necessarily going to match the results that you would get theoretically if you conducted the same experiment or if you gave the same survey or whatever to the whole population. So if, say we were doing our first year undergraduate students is our population, and you only sampled people who were in psychology classes because that's who I have access to. That would be a biased sample because, well, what about people in engineering? What about people in the arts who are doing English or art or anything else? Those people are not represented, and so our sample would be unrepresentative. And in that case, our population, even though first-year psychology students are part of the population of first-year undergraduates, we wouldn't be able to generalize the results from that sample because it isn't representative of the sample. So that's for a biased sample. If we had an unbiased sample, then it's representative of the population. I could have a couple of psychology undergraduates. I could have a couple of engineering students. I could have some English majors. By getting a random selection of students who fall into our population, then I would have an unbiased sample that gives us a much better representation of the population. And so for an unbiased sample, it comes from the population and should be generalizable to that population. So that's where our distinction is here. So sometimes you can generalize and other times you cannot. And so we're going to look at the specifics of biased versus unbiased samples, how we can get them, and what means for research that's conducted using these different sampling techniques. Now, to give a little bit of a clearer idea of some examples of biased and unbiased samplings, we can take a look at this table from the textbook, where we're going to look at our population of interest and then a couple of ways that we could sample in a biased fashion and ways we could sample in an unbiased fashion. So first, we have population of interest is Democrats in Texas. So if we wanted to look at the opinions of a particular political group in a particular state. So we're going to start with biased or unrepresentative sampling. And you could get a biased sample by recruiting people sitting in the front row at the Texas Democratic Convention. So you can go to a political event that is for our particular group of interest, and you could survey only the people in the front row. Now, this is a biased technique because there isn't any kind of random choice. And we'll talk about randomness on the next slide. But we're just picking the people who are at the front of the room. What about people who didn't go to this convention? What about the people who are sitting at the back of this convention? So our sample, if we're picking the people who are sitting in the very front row, maybe they're people who paid to have seats in the very front row. So maybe they're very wealthy. Maybe they're very important within this particular political group. So we're not getting a good representation of all Democrats. We would only be getting sort of this one particular type of Democrat. And that's why it's a biased sample. For an unbiased sample, you could get a list of all registered Texas Democrats from public records. So you could go to, I don't know where they would keep these public records, possibly an online list. And this list would have everybody in the state who has registered themselves as a Democrat. And then you could choose a sample of people from that list by using a randomized event. So maybe you use a random number generator. You draw names out of a hat, something like that. And you would just take anyone from this list has a chance of being sampled. And that's why it's unbiased. We'll do one more here. If we were looking at our population of interest being drivers, if you set up your sampling base as standing near a bunch of parking meters, maybe you're waiting on campus near the parking on the street, and you could stand next to the meter, the machine that lets people purchase a ticket so they can park there. If you ask all of the drivers who come up to that machine to participate in your survey, then you're only getting drivers who are in that particular area and who drive and park at parking meters. So if we're using a parking meter near campus, then you're only getting students for the most part. So this is definitely a biased sampling technique because we're not getting a good representation of all drivers, because not everyone is going to be coming to that part of town. Not everyone is going to park at a meter. So not the best technique. Instead, we could, again, obtain a list of all of the licensed drivers in each state or province and select which ones on that list we want in our sample, again, using a random number generator or pulling names from the hat. So this term random is going to be really important when we start looking at our unbiased techniques. So if we introduce this method of randomness, it tends to help us get a better and more representative sample. Before we start talking about getting our unbiased samples, I want to talk very, very briefly about biased samples first, because it's surprising how easy it is to accidentally end up with a biased sample. And we see a lot of these biased samples without even realizing that we're seeing them. So we're going to talk very quickly about two of the most common types of biased samples that we get, and we care about having biased samples available to us because having a biased sample is going to reduce our external validity. And if we remember, external validity is our ability to generalize the results from the study on our samples and to generalize those results to the population as a whole. So like we said at the beginning, if you have a biased or unrepresentative sample, then your results aren't necessarily going to represent what the whole population would have done on that same study. So the first of these types of bias samples is called convenience sampling. And luckily, this one is kind of what it sounds like. So you sample only those people who are easy or convenient to contact. So our first example is perhaps you're going to conduct phone interviews. And that's what this data here is showing us. So maybe you have a phone book and you're going to go through your phone book and pick people to be in your study. Even if you randomly selected people from your phone book, what if that phone book is only giving you people who have a home phone number, a landline? The phone book doesn't include cell phone numbers. So your sample, even if you have randomly chosen people to be part of your study, you started with the possibility of not everyone being included in your study. You're only including people who have a house phone, people who have a landline. And so in this example here, we're looking at conducting a survey about different kinds of health behaviors. So asking people, are you a smoker? Do you drink often? Have you had your flu shot recently? And if they only get in contact with people who have a landline, our numbers are going to be different than if you contacted someone who, say, only uses a cell phone. So the distinction here is these are people who have a landline at all. And so if you contacted using a phone book, you could get a hold of these people. If somebody only uses a cell phone, maybe their cell phone is their primary form of contact and they got rid of their house phone, these are the people here. And we can see that if we only sampled landline owning households, we'd only get about 48% of the population, because another 48% of the population relies on a cell phone instead of a landline. And we can see how this would be a massive problem if we start looking at the numbers. So current smokers, people who have a landline, are a lot less likely to be smokers than people who rely only on cell phones. Drinking is different, and even flu vaccines is different. So what's going on here? Well, because our sample is biased, we're only looking at people who had landlines in this theoretical example. We want to think about how people who have landlines versus people who only have cell phones might differ. And for most cases, people who have a landline are going to be an older group. So a lot of younger people only have a cell phone and they don't feel like they need a landline. So we're seeing not just a difference between, oh, you have or don't have a home phone, we're also seeing sort of some demographic differences that are influencing whether you have that landline or not. So people with a wireless only contact method are going to be younger, and that's going to be influencing some of this stuff as well. And people who have a landline still are generally older. So if we only sampled people who have landlines, we wouldn't be getting the whole picture for the whole population. And there's even more that we'd have to consider. So if you were conducting a phone interview of all of these different health behaviors, you're missing out on people that don't have phones at all. And again, there's some demographic differences here where people who don't have a phone might be low income people who just can't afford a phone. And these numbers differ yet again from what we'd seen in the other groups. So you can't just look at one subset and assume that the results you're getting apply to the whole population. You have to make that effort to have an unbiased sample and get a sprinkling of each of these groups to get a better picture of the population as a whole. Another example, just to give another way of thinking about this, is if we look at, say, the people who do online surveys. So convenience sampling is going to be we're getting people who are easy to reach and who are motivated to conduct online surveys. And so you have to consider that people who want to earn money participating in research online, maybe they're going to be different than people who don't do online surveys. And maybe some people are motivated by making money and who aren't making money. So we can have differences in personality traits, differences in socioeconomic status. People who have a computer who can spend time on surveys versus people who don't have a computer. And so we get lots of differences that you have to take into account because these surveys aren't getting a representative sample. They're biased based on who they can reach, who is convenient to contact with these surveys. On the topic of surveys, there's another thing we have to consider, and this is the idea of self-selection. And so this happens when you're sampling only people who volunteer. So you're not giving the sample to a random assortment of people. People are seeing a survey and choosing to participate. So we often see things like polls, kind of like this one here. So asking, would you keep your child in a rear-facing car seat? And it's to consider if this is a representative sample, if we should be able to generalize these results, we'd kind of have to know where this sample came from. If this was, say, a poll that was done at a community center where you have classes for new parents, and then there's a kiosk in the entryway where new parents coming in to take those classes could select that, yes, they would use a rear-facing car seat, or no, I won't keep a rear-facing car seat, or I'm not sure. But the people who did this survey are those who noticed the kiosk and decided to answer. So they self-selected because they saw it and chose to participate. If we go back to surveys, things like Amazon, where you can look at ratings given by people who have bought products, you have to consider that the people who review a product are people who have been motivated in some way to review that product. So maybe they got it and they hate it. So they self-selected, they decided that they would go online and leave a review. So you could see a lot of negative reviews piling up because only the people who are really angry about the product decide to leave a review. But if you get an item and you're satisfied with it, it's not amazing, but it's not terrible, you're probably not going to leave a review. So that's another case where this self-selection can bias our results because you're only seeing the survey data, the information from people who chose to give that information. So lots of situations where that can be problematic. And so if that's the problematic side of things, that's our biased sampling side of things, then how do we go about doing this right? How do we go about getting a representative sample? And the best way to get a representative sample is going to fall under the broad category of probability sampling, or random sampling. So I've seen it more often as random sampling, but the two terms are going to be used pretty much interchangeably throughout the textbook. So probability sampling just means that every member of the population of interest is going to have an equal chance of being selected for the sample. So there aren't going to be people excluded from your sample just because of how you're sampling. So if we think about only taking the front row of people at a particular convention, that has excluded the people who didn't go to that convention. For probability sampling, we would start with the whole population of interest, and everybody has an equal chance of being selected. And we're going to be using random techniques, lots of random number generation, to try and pick which person from that whole population we're going to use in our sample. And so we're going to break it down into different types of random sampling or different types of probability sampling, because each one seems to be useful in different situations. But the important part is that every single one of them is going to involve some random element that allows us to get this representative sample. And we'll point out that random element as we get to each of them. So the first is going to be simple random sampling. And this is what we most often think about when we're talking about random sampling. And so what you would do is you put every name from all of the members of the population of interest into a pool and select your sample. So I've used a bingo machine here. So maybe on each ball, each number represents a different person, and whatever number comes out first, that's the first person in your sample. Or you could go a little bit less technological, and you could have every person in a classroom write their name on a specific piece of paper, make sure that all the pieces of paper are the same size, and then you fold them up the same way and put them all in a hat. And you shake the hat around and you pull names out of the hat. So everybody in the class whose name is in the hat has an equal chance of being selected as your sample. We could go more technological and we can start using random number generation. So if you have 100 students in our class and I wanted to pick a sample of 10 students to represent the class, I could use a random number generator like the research randomizer or my site of choice, random.org. And you can say, okay, I have 100 people, pick 10 for me. And if we had our class list, maybe we put you in alphabetical order, and someone whose last name starts with A will be number 1, and someone whose last name starts with Z will be number 100, and everybody in between gets a number. These sites will spit out a series of numbers that correspond to a person. So because we're using this random event, either pulling a name out of a hat or a ball out of a bingo cage, or getting a random number from a site designed to give random numbers, everybody has an equal chance of being in our sample. So everyone in the population is going to be equally represented. Now, that's the good side of this. The trouble is, it's not always easy to get every single person in a population of interest. It can be really difficult to get absolutely everyone. Say if we were looking at, pick a difficult example. If we were looking at everybody over the age of 60 who hasn't yet retired, I suppose we could go to the government and get tax records and see who's still paying into retirement plans, but people are going to be missed. So this method isn't usable unless we can get a list of everybody in the population to start picking from. So this isn't the best case for some situations. So other times we're going to have to use a different method, or a variation of this method. Our next method is going to be cluster sampling. So you will randomly select a pre-existing cluster and sample everyone within that cluster. So the example that I'm using is, say you want to sample high school students within Alberta. So we'll say that these are all schools. And we'll simplify it. We have 10 schools here. There is 10. Okay, good. Quick counting. So if we have our clusters, so each school would be a cluster, and we want to pick a subset of these schools, a couple of clusters, and then sample everyone within that cluster. So we can use our random number generator. And I say, okay, I have 10 schools, and for my sample, I need you to pick 3 schools for me. So I say, okay, there are 10 options, pick 3. And our random number generator gives us the numbers 7, 1, and 8. So of all of the possible schools we could have looked at, we get 1, 7, and 8 because the order doesn't really matter. And so these are our clusters, and what we would do is every single student at school number 1 would be part of our sample. And every single student at school number 7 is going to be in our sample. And every single student at school number 8 is also in our sample. So this is how we would cluster sample. Another example would be maybe you wanted to get a feeling of, let's go back to the study that looked at comments made during children's hockey games. So they would show up at a randomly selected hockey game, a cluster, and then they would record all of the comments made by parents at that hockey game. So we measured every single comment within the cluster, which was our hockey game. And of course, some of the restrictions here being, maybe it's not viable to get every single student at the schools that are randomly selected to be part of your sample, which leads us to a variation of cluster sampling, which is going to be multistage sampling. So instead of getting a cluster and then measuring every single person within that cluster as your sample, multistage sampling has us randomly select a pre-existing cluster and then sample a subset of that cluster. So we're going to have 2 stages of random sampling. So same setup, still have our 10 schools. We're going to have our random number generator. Say we're saying that we have 10 schools, pick 3 for us. And this time around, they're going to pick 3 different schools, and that's fine. So we have school number 1, number 4, and number 10. Now, instead of in cluster sampling, where we'd take all of the students at 1, and all of the students at 4, and all of the students at 10, maybe we only need 50 students from each school to be in our sample. So for each school, we would take our total population. So we'll just look at school number 1 for our example. Say school number 1 has 1,000 students, and I only need 50 of them to be in my study. So I would get a list of all of the students at that school. I'd go to the main office and ask for their student list. I'd give all of those names on the list a number, and I'd tell the random number generator, okay, of the 1,000 students that we have, randomly pick 50 of them for me. And so whichever students are identified using this second random event, those students are part of my sample. So multi-stage sampling is just cluster sampling plus an extra stage of random sampling. So it's multi-stage, there are 2 stages. Next, we have what's called stratified random sampling, which is going to be yet another expansion. So this is a type of multi-stage technique, but instead of this stage where we would completely randomly choose from our individual clusters, stratified sampling involves selecting a specific demographic category. So maybe you want to make sure that you are getting a good representation of a particular race or gender, and then randomly select individuals from each of those categories so that you equally represent the particular race or gender of interest. Now, this technique is particularly important when you're trying to represent, say, these demographic categories that make up only a very small proportion of your population. So the example that the textbook uses is that maybe in your sample, only 4% of people from, we'll say, Canadian schools, only 4% of them are of South Asian descent. So we only have a very small portion of people for our South Asian descent, and we want to make sure that because this number is so small, that if we used completely random sampling, then we might actually end up missing this category entirely just through random chance. So if we think about, if you flip a coin 100 times and you expect to get 50 heads and you expect to get 50 tails, but there's a little bit of wiggle room because of randomness. So maybe you got 60 heads and 40 tails. So there's a little bit of room there. If our group of interest within that population is very, very small, through chance, our supposedly random sample might actually give us 0%. We might not get a proper representation of this category. So to try and get around that, to avoid accidentally missing something, missing a part of our population, we could choose to try and get our 4% specifically from that category. Or we can also call this category a strata, a particular group. So if we have our total sample is going to be 1,000 people, and we know that we need 4% who are of South Asian descent, that means that we need to pick 40 people. And so what we would do, instead of completely randomly sampling, is that we'd use our list. So we'll get all of the names of everyone within our population who is of South Asian descent, and we would randomly select 40 people from the list of possible people who have that particular, who fall within that particular category, so that we are sure that we represent them equally. So if we had, so this is what our sample is. This is our ideal sample. If our whole population is going to be, let's just add on let's just add 1 0 because I don't want to do math. Which would mean, okay, so if this is our total population, so if we had 10,000 people to pick from, we're supposed to pick 1,000 people, and we want to make sure that of our sample of 1,000, that 40 of those are going to be of South Asian descent, so that we know that we have represented that very small proportion of the sample equally. We would then look at the total population where we have 400 people of South Asian descent, and from this, we would randomly select 40 people to be part of our sample. For everyone else, for the rest of the population, if we're not concerned about having an underrepresented demographic category, if we're not concerned about the other proportions, then the rest of the sampling, we could pick the other 960 people. Yeah, we could pick the other 960 people at random, using our multistage technique as per normal. But in this case, we want to very much focus on representing our potentially underrepresented demographic category. So this is really important if you very much care about getting a good look at a particular demographic category within your whole sample. So this is a very special case, but it is an important one. And again, we're going to build on this just a little bit and look at another slightly modified technique, and this is oversampling. So this is going to be a variation of our stratified random sampling, where our researchers will overrepresent that group of interest, that particular demographic group. So we're going to use our same example from before, where we have 4% of the population come from South Asian descent, and we want to make sure that we accurately represent these people. We don't want to miss them. But we've also made the realization that if we pick 40 people to get our sample of 1,000, 40 people of South Asian descent, an N of 40 isn't going to give us very clean statistics. Maybe that's not going to be enough for us to accurately get the statistical conclusions that we need to talk about this sample. So because this number, this 4%, is such a small amount, maybe we have to do something to compensate. So instead of pulling 40 people from our available, we can do this again with 400 total. Maybe to give us more people to have our statistics run properly, maybe we're going to pull from this 400 available people in the population, we'd pull 100 people who are of South Asian descent. And we could use this 100 as an oversampling, sort of extra people to give us more confidence in our statistics. And then after we run our statistics on this larger sample, this oversampled population, we could do some adjustments where we bring our numbers down overall so that we would treat this 100 people proportionally as 40 when we look at our total sample. So you'd run your statistics using 100 people, but you would report the results, the final part at the end, saying that this is proportionally what it would be after we have compensated for the fact that we needed extra people for our statistics. And so again, this is a very, very specific situation where you're going to have a very small part of your sample, a very small part of the population that you need in your sample, and you need extra people to make your statistics work. This is the method that you use. But for the most part, this is going to be a pretty rare method. It's just a good idea to talk about them. Our next method of representative sampling is a little bit of a weird one. And I had to read this one through a couple of times, so we'll have visuals for this one as well. But this is systematic sampling. And so this is a case where you have your population. We can use an example of students in the classroom. And you're going to randomly obtain two numbers. So maybe you're going to roll a dice. You would roll a die, I suppose, is the singular. You roll a die 2 times. The first number tells you where you start. So if you roll a 5, you would start at the 5th person in the class. Then you roll another die. You roll that same die again, and that number tells you how many people you skip before choosing the next individual. And that is conceptually weird to grasp, especially for those of us who are visual learners. So I found some visuals to use. And I was going to use people and have images of, say, stick people to represent a class. But then I saw that they had icons that were dinosaurs. And why would I use people if I could use dinosaurs? So these dinosaurs are in our class. And if our first number is the number 5, then we say that we start with the 5th dinosaur. So 1, 2, 3, 4, 5. This dinosaur is our first part of the sample. This is the first member of our sample. Our next die roll, say we roll the number 3, tells us how many dinosaurs, or people, I suppose, we skip before we get to our next sample. So we're picking the 3rd person. So we picked this person, so now we're going to skip to 1, 2, 3. And then we skip 1, 2, 3, 1, 2, 3, 1, 2, back to the beginning, 3. And you keep going on and on and on until you get enough people or dinosaurs for your sample. So if I needed only 5 individuals, this is how I would get 5 individuals. And for how I've counted here, I'm I'm not sure if this counts as you skip 2 and you pick the third, or if you're supposed to skip 3 and pick the fourth. As long as you make it clear in your methods, both count as systematic sampling. You just have to tell people how you employed that sampling method. But hopefully that visual helped tell you what was going on there. Now, if you've ever done research or if you've ever read a bunch of research papers, you might be thinking that none of those methods of probability sampling seem to have matched what you've seen in the real world. And that's probably very likely, because sometimes we're going to see a combination of techniques or a modification of those techniques to make them work in whatever situation you're in. So what we've talked about are kind of our ideal setups and the base way of doing this kind of random sampling, but there can always be variations. And in a lot of cases, we can see combinations of these types of sampling. And for the most part, when you're actually doing the research, you're not going to talk about, I used a systematic sample technique. You would probably just describe the way that you sampled your population. And if somebody wanted to apply the correct term to it, they could. At least in my experience. In the area of research that I've had, we don't focus too much on the titles. We just focus on trying to have some kind of random method of sample selection so that we're sure that we're getting a representative sample. And so we've talked about our probability sampling, our methods of getting a random sample or a representative sample or an unbiased sample. And we're going to look at non-probability sampling, which we've touched on very, very briefly. So we talked about our convenience sampling already, but we'll talk about the others a little bit later on. But we're sort of making this visual distinction between our types of probability sampling and our non-probability sampling, or non-random sampling, which is going to be giving us a biased sample or an unrepresentative sample. So lots of words that mean the same thing when we're talking about these different topics. Now, before we go too much further on and get into our non-probability sampling techniques, I want to spend some time distinguishing between random sampling and random assignment. And so random assignment is something that you might be familiar with from talking about experimental research in other classes. So if you have taken introductory psychology, I know we've talked about random assignment. So let's take a moment and clarify the difference between the two. So random sampling is what we've been talking about. It's the method that we're using to obtain our sample from our population. And having random sampling is going to function to increase our external validity. So if we get a good, random, unbiased sample, then we're going to be able to generalize our results to the larger population because our sample is representative of the population. In contrast, random assignment is used pretty much only in experimental designs, and this is the method that we use to assign participants to a group at random. So when we look at an experiment, you could have somebody in a control group and someone in an experimental group. Random assignment is how you decide who's in the control group and who's in the experiment group. And random assignment is a method for us to increase our internal validity. So instead of external validity. So internal validity is going to help us make sure that we're measuring what we're trying to measure. And we can take a brief aside here. So if you had a problem with your random assignment, if people weren't spread out into the control and the experimental group, or in the terms that we've used so far in this course, the treatment group and a comparison group, if they weren't randomly assigned, then one group might have a bunch of the same trait that the other group doesn't have. So my go-to example for this is random assignment in, say, undergraduate research participation. So if you remember back to Psych 104 and 105, you had to sign up for a study and usually go to a room. And once you got to the room, the experimenter would put you in a category and sit you somewhere to take part in an experiment. If the researcher just said that the first 5 people to show up are going to be in my experimental group and the last 5 people to show up are in the control group, then all of a sudden our experimental group is going to be made up of people who get to places early, maybe people who are keen and excited, or maybe people who just have a really good sense of direction. And all of the people in our other group are going to be people who were late, who showed up later on. Maybe they got lost. And so by having those traits differ between the groups, what you're measuring in your experiment might not be the effect of whatever treatment you're giving them, but you might just be measuring pre-existing personality traits. And by measuring something that isn't the thing you're interested in, your treatment, you're decreasing your internal validity because you're measuring something else. So having random assignment, having people to be spread out between the two groups randomly gives you better internal validity. And internal validity is measuring what you intend to measure within that experiment, whereas external validity is telling you if you can apply your results to the broader population of interest. So those are our distinctions. We'll do more on random assignment, of course, when we start getting into those chapters, but I figure it's a good place to bring it up here so that you don't confuse the two. And so from there, we can move on to the promised non-probability sampling techniques. So these are the 4 ones listed in this table here. Our convenience sampling, which we've already touched on. So convenience sampling being samples that are easy to access or convenient to get to. And the textbook uses the example for convenience sampling. They seem to be obsessed with US politics. So they said maybe you want to poll voters. So if you're looking to get an idea of which way the election is going to go before they actually tally all the votes, maybe you're going to station people outside of polling stations to ask voters as they come out who they voted for. And in America, this is a thing that they do. And the people asking the questions are called pollsters, and they'll go out to different polling stations and they'll ask voters who they voted for to get a feel for which way the election is going to go. A convenient sampling in this situation would be that maybe the pollsters go to areas that are nearby. So if they're all coming from a particular news agency to get reports to that station so that they can put it up on the news, then maybe they're going to go to the polling stations that are next door. Maybe they're going to go to the one down the street. But those polling stations are convenient, but they're not necessarily giving you a good idea of the whole population because you're only looking at one small area. So if you're living or if your news station is in a rich part of town, then maybe you're only polling relatively wealthy individuals who have voted. What about other parts of town? Maybe you want to go to the bad side of town. You have to cross the tracks. You should poll people there as well to get a representative sample. So this convenience sampling, only polling people nearby, means that you're missing people who aren't nearby. And another thing that they talked about, or another way of having a biased result through this convenience sampling, still with polling results, is if your pollsters are only comfortable approaching a particular demographic. So maybe the younger pollsters are only comfortable talking to people who are the same age. Or maybe you're only comfortable talking to people of the same gender. So through convenience, they would only ask the people they're comfortable approaching. And so again, if you're only comfortable approaching young people, well, maybe you're only going to get a younger view on which way the election is going to go. And so yet again, by picking people through convenience, you're not getting a good representative sample, and you're getting a biased sample that's not going to give you a good idea of what's going on in the population as a whole. Okay, so that's enough about convenience sampling. The next type of non-probability sampling is called purposive sampling. So where you are surveying people on purpose. So you recruit only those types of participants that you want to study. And this one you kind of have to take with a grain of salt. So if you wanted to recruit smokers, then you might have a purposive sample. But you have to consider how you have gotten those smokers. So if you started with a list of the whole population of the town that you're interested in, and you called everyone who was randomly selected from that list and asked them if they were a smoker or not, and your sample was only the people that said, yes, they're a smoker, that is not a biased sample. If you sought out smokers by sampling people who went to a tobacco shop, a particular tobacco shop, that is a purposive sampling. It is a biased sampling because the whole population didn't have the equal opportunity of being in that sample. So for these, we have to be really careful about specifically how you obtain that sample, not just the fact that you're only getting smokers. So keep that one in mind. Our next technique is the snowball technique, which is going to be building off of our purposive sampling. So you're only looking at smokers. But once you have some people who are smokers in your population, or who are smokers in your sample, you then ask your people in the sample, your participants, if they could recommend other people who are also smokers. So but once you have a couple of participants, you ask them to get you more participants, who then get you more participants, which is a snowball effect. So as you get more people, you can collect more, and it builds up like a snowball rolling down a hill and getting larger. But because we're picking up extra people through this social network and not through random selection, it's not going to be an unbiased method of sampling. So this is a non-probability technique because we're not using random sampling to get this population. This is really, really common in a lot of medical research. So if you're studying a very rare disease, say Crohn's disease, if you could find a couple of people who have Crohn's disease, you might then ask them if they know others who have the disease, possibly through support groups. And so it helps you as a researcher try and get more people in a very small subset of the population, because not many people have Crohn's disease. So this snowball sampling might actually be the only way that you can get a large enough sample. So this is one of those where you have to consider the pros and cons of using this method, because it's not going to be representative. We're not randomly getting these people, but it might be the only option you have. Oh, sorry, did not mean to click. So for our last type of unrepresentative sampling, we're going to look at quota sampling. And this one, instead of building off of some of our other non-probability sampling techniques, actually ends up looking very similar to our stratified random sampling that we talked about earlier. So quota sampling, you're going to have a researcher identify the subsets of a population. say, the different proportions of the population that are made up of different ethnic backgrounds. So with our South Asian example, maybe you're going to also identify people who come from South America or wherever. So you decide your divisions, and based on the proportion of people in your population, you're going to set a target number, a quota, for each category that you've set aside, and you're going to go and find people to fill out your sample so that your sample proportionally matches your population. So this sounds very, very simple or similar to our stratified random sampling, but it's a non-probability sampling technique if you don't use random selection to fill your quota. So if you go and try and find people to fit into each category that you care about using a non-random or non-representative manner. So maybe you need to find a bunch of people who are of South Asian descent, so you go to a community center in a part of town that has a lot of people of South Asian descent. That is a non-random method of sampling because not everyone in the population has a chance of being selected. You'd have to be looking at the population as a whole to get a random sampling if you wanted a good representative sample. So quota sampling is going to be when it's done in a non-random manner. So that's our representative sampling and our unrepresentative sampling. And now we're going to take a brief pause and come back to the idea that when we're looking at sampling methods, it's not just for frequency claims. As we said at the beginning, we can use observational, sure I'm saying this right, we can also use things other than surveys for our frequency claims. So as we said in the last chapter, we can have observational research that can also be used for frequency claims. So we had, last time around, we talked about the experiment where they had people wear voice recorders, and the voice recorders would turn on periodically throughout the day, and you would take a transcript of all of the words spoken whenever the voice recorders turned on. Now we could set up that sampling method to also be random. So we could have our observational research set up in a random fashion. As is, if we wanted to evaluate this experiment for its randomness, for its representativeness, we'd have to consider, how did they choose the participants? Where did these males and females come from? If they were just chosen by convenience, if they happened to be students in undergraduate psychology who had to take credit or who had to do this experiment to get a credit, that's not exactly a representative sample, and we would have to keep that in mind for evaluating the generalizability of these results. So observational research can also make benefit of using these different types of sampling methods. It doesn't just have to be for surveys, for getting people to fill out surveys or polls or whatever. This can be used kind of in a lot of places. So on that topic of critically evaluating things, we should start thinking about, what is it that actually matters? So when we're looking at our frequency claims, which is what this section of the textbook is all about, our external validity is definitely a priority. Because if you're making a statement that X proportion of this population believe this thing, then we should be really confident that our sample is actually allowing us to generalize to that population. So for a lot of our frequency claims, it's really important to have that generalizability, to know that we have a representative sample and that we can be pretty confident in that claim, that broader application. But it's not always the case that external validity is essential. We can run into some special situations where external validity could be a much lower probability or a lower priority. So let's look at some examples. So non-probability samples in the real world, and we'll use some of this critical thinking to see if we feel that it's important to have a representative sample in all situations. So real world example, let's say that somebody has a traffic app on their phone. The textbook talks about using the Waze navigation app. I'm not familiar with that app. I just use Google Maps. But on your phone, you can report that there's traffic up ahead. So you could take some time, maybe pull over after getting through part of your traffic, or maybe get your passenger to go into that part of your phone and report that there's a traffic jam. Maybe there's an accident. Now, you have self-selected to give that information. You have volunteered yourself to provide that information. And so if you were evaluating whether or not you trust that there's traffic, you kind of think, okay, well, this isn't a representative sample. This is someone who decided that they would tell us there's traffic ahead. But that person doesn't necessarily benefit from giving that information. They're not telling that information because they're angry about the app. They might be a little bit flustered about the traffic, but they're sharing that information to provide that information to others. So the feature or the trait that made them provide that information doesn't actually affect the information that's being provided. So that person provided the information maybe because they're conscientious. Maybe they wanted to make it available to others so that other people could avoid the traffic and go another route. So we can have a pretty decent idea that the person deciding to give that information wasn't having other motives. And so it being an unrepresentative sample or a non-probability sample isn't that big of a deal. We don't care. So in this situation, yeah, it's fine that it's not a random sampling. The information is still valid and useful. If we want to think about non-probability samples in research studies, maybe we can think back to the last chapter when we looked at a camera crew following that dual income family around after they got home from work. So this camera crew is following the parents and their children around to figure out how they talk to each other and what they talk about over dinner. So let's critically evaluate here. The people who are in that study, the people who say yes and agree to have a camera crew in the house, those might not be a good representation of the population as a whole. If we think about it, maybe families that are, if they know that they're not very positive, maybe if they know that they are very bad at interacting, maybe they yell at their kids a lot, they're probably not going to want a full camera crew in their house recording and documenting what's going on. So the people that say yes might be people who already have a more positive conversation with their children. So in that case, we would have to be careful about taking the results of that research and applying it more broadly, because the sample feels pretty biased, and the way it's biased might actually be influencing the results. So to decide if it matters, if it's a non-probability sample or not, we have to figure out sort of where's this information coming from, what is motivating someone to be in or out of the sample, and does that motivation start affecting the results? So critical thinking depending on the situations that we're looking at. Now, our last part of the textbook is trying to actually dispel a little bit of a misconception. And I like that they've included this. So when we're looking at choosing samples, and I've experienced this in setting up research, if you ask your supervisor, well, how many people do I need for my sample? The statistically correct way to say it is that you choose the number of participants based on the power of the thing that you're trying to study. So you can statistically calculate the number of participants that you need to see the particular effect that you're looking for. So you can mathematically figure out about how many people you need. In practice, you're usually told that the larger the sample, the better it is. So if you can get more subjects, if you can get more people in your study, that is going to be better. Now, the textbook spends some time talking with us about the fact that this isn't always the case. So if we have a very small sample, we spent a lot of time making sure that it was a representative sample. If we used our random methods to obtain this sample, we would be very confident that we have a good ability to generalize our results back to the broader population of interest. If you had a larger sample, if it was still representative, then it's good. You have more statistical power. You have a little bit more resolving ability. You can get better statistics with a larger sample if it's representative. And that's the important part. If you end up with a larger sample, but that sample is not representative of your population, then it's not really telling you anything useful anyways. So having a large sample that you obtained using non-representative methods, then it's pretty much useless to you. So if you're reading a paper and they're talking about their sample and they have an N or a sample size of 1,000 people, you might be impressed. But before you get too excited, look at how they got that sample. Because if it's a biased sample, then having a large N is not going to help them at all if they're trying to generalize those results to the population as a whole. And so this table here is actually talking about why having a larger sample that is representative can be helpful. And so here they're showing the percentage. So this is just our sample size. So if we have our sample size, we can have a very large sample or a very small sample. If we have a very large sample and it is randomly selected, or if it is representative, then that helps us have a very small margin of error. So this is a statistical calculation looking at how much variability is in our data. So having a larger sample lets us be more confident in our results. So margin of error might be reported, say we're talking about, say 50% of teens have smoked marijuana. If it was reporting the margin of error, it would be 50% plus or minus 2%. So that's giving us an idea of how much variability is in our data. And so that would be based on a sample of 2,000 teens. But if we only looked at 50 teens, even if it's still a random sample, even if it's still representative of the population, our margin of error is much larger. We have plus or minus 10% just because the sample size is smaller. And these are statistically calculated, and it's something that we'll look into later on in the course. But just a very brief outline of bigger can be better, but is not always better. All right, so that is the end of the textbook side of things. Now I want to take just a minute and look at some real-world applications. So I actually want to walk you through how I have set up experiments in the past using some of the methods that we've looked at in today's lecture. So a real-world example, I am not expecting you to memorize anything about black-capped chickadees. Just take this as showing you how we might make use of random sampling techniques in a real-world application. So my background, because not everybody's familiar with black-capped chickadees, these guys are black-capped chickadees. They are very small songbirds. They are spread across most of North America. They have a range from the East Coast to the West Coast. They go really far north. They even go really far south. When I say small, they're maybe 10 or 12 grams. So they're tiny and they are light. And I care about these guys because they're vocal learners, which is pretty rare in the animal kingdom. So humans are vocal learners because we learn to speak from listening to and modeling our responses after our parents. And black-capped chickadees and other songbirds have the ability to do the same thing. They learn their vocalizations and shape them based on what they hear from adults of the species. Most animals cannot do this, which is why I have been studying black-capped chickadees and how they vocalize. And so most of communication with these guys is done vocally, so they don't have a lot of visual displays. So pretty much everything is done through vocalizations. And so my research question has been, is there a way that I can tell male and female produced vocalizations apart? So if I listen to a chickadee call, can I tell that it was made by a male, or could I tell if it was made by a female? And now my ears are not accurate enough to be able to tell this just by listening to them. So I would be using a computer program to do these measurements, but that's besides the point. So if we wanted to start looking at, okay, how do I select a sample? Step one is, what's my population of interest? Ideally, I would like to look at all black-capped chickadees. But like I said, they have a really wide range. They're here in Alberta. They're on the East Coast in Nova Scotia. They're further north. They're very south. And I really only have access to chickadees that I've recorded here in Alberta. So my ideal population is all black-capped chickadees, but in reality, I can look at black-capped chickadees from Alberta. So my population of interest will be more realistic, and we'll say I'm looking at the ones that I recorded here in Alberta. And our sample is going to be a subset of the males and females that I have access to recordings for. So I've gone out in the field with my recording equipment, and I can document and record all sorts of vocalizations from these birds. So how am I going to go about choosing my sample? I'm for sure going to want to use a random number generator. I don't have sort of an ideal situation. So my first thing that I'll ask is, out of all of the recordings that I have available, how many males do I have? Let's say that I have 67 males. Okay, how many females do I have? Maybe females are harder to get recordings of, so maybe I only have 42 individuals here. How many of each do I want in my sample? I'm going to want as many as I can get, but I want to be using random selection here. So in obtaining my recordings, there's a little bit of randomness on that side because I have been going out and it's whoever I encounter, but that's not ideal. So we want to introduce as much randomness as possible within the restrictions of what I have here. So maybe I want 30 birds each for my sample. So how do I go about doing this? I could have a random number generator. So I can use my RNG, and I can say, of these 64 males that I have, pick 30 for me. And so I would start with a list of all of the birds that are males that are in my sample, and I want you to pick 30. And this is the cool part. I'm actually going to show you what it looks like to go to random.org. And so here, if you just want like a single random number, you say, pick a number between 1 and 100. They have that right on their main page. But I'm more looking for, out of the 67 birds that I have, pick 30 for me. So I would be going here into, I believe, yeah, here we go. So I want a random list of numbers. So I want 100 random integers. Nope, I don't want that many. I want 30. I want 30 birds chosen from my list, and I want them to be between 1 and 67 because I have 67 birds. And that's not really that many, so we'll just put them into one column. So I would say, yeah, that's what I want. And so here we have 30 numbers that were chosen between 1 and 67. So I would go through my list of birds and I would say the 21st bird is going to be in my population, or is going to be in my sample. My 46th bird will now be in my sample, and so on and so forth. So this is how we randomly choose our sample from what I have available. And we could do that or similar with our female. So I said we only had 42 this time. But I still want to pick 30 birds to go in my sample. So we're going to pick 30 out of these 42, and it's going to give me a different list that have been randomly selected. And so this method will be kind of similar to our random stratified sampling because I'm choosing from the available males and females to give me a 50-50 population representation. The assumption being that there are about equal males and females in the whole population of chickadees. So I want my sample to also have a 50-50 ratio. So that's how I would do the sampling part of it. So if I want to do some critical thinking about how I got my sample, if I ran my experiment and I could look at the acoustic qualities of their vocalizations, and I could say that the males make higher pitched vocalizations and the females make lower pitched vocalizations or something like that. Now we can think critically about it. Let's look at the generalizability of what we got. So could I actually apply these results to all chickadees all across Canada? Not really. But maybe I would feel comfortable generalizing to chickadees from Alberta, because I got a sample from a couple of different places within Alberta. So when would I actually be able to generalize? If I wanted to apply broader, but I wasn't able to sample broadly, how else can I get there? And the easiest way to do this is if someone else, or I guess if I, did a study, the same kind of setup, but using different populations of chickadees. Maybe I looked at chickadees from Nova Scotia. If they had similar results, then I'd be a little bit more comfortable generalizing. But these are the things we have to consider when we're stuck within our research paradigm. So hopefully this gives you an idea of some of the things that we consider when doing real research. But like I said, you don't have to memorize all this chickadee information. I just want to give you an idea of how this stuff works actually in the real world. And we will leave it there for today.